So to get to the point where we can actually express this postcondition, let's break it into two parts. And the first part is going to be the part where the output is going to be ordered. And the question is, what does it mean for a vector of integers y to be ordered? So let me give you another chance on that part of it to state in English what it means for a vector of integers y to be ordered. Precise English.
For every element in y, if there exists an element that is after it, then that element must be greater than or equal to the current element we're looking at.
Almost there, okay? What Jared did is he broke the specification into two parts. One part is all the elements except the last one, and he stated exactly what the postcondition is for that, but he didn't say anything about the last one, okay? Mm-hmm. So if we wanted to have a precise specification, we'd have to deal with that one as well, mm-hmm. Okay? Now, it turns out in this particular case that we could do a little proof in our head to say that if the postcondition that he specified for all the other elements is true, that implies that the last one must be the greatest one. So we could get away with that, and in fact, that's a pretty nice, clean way of expressing it. Notice also that Jared used the word for each, and when you hear that phrase, it's suggestive of, in our first order logic, of one of those quantifiers that I mentioned, the universal quantifier for each or for all. And so we're going to see when we specify this in first order logic that that quantifier is going to be there. In first order logic, when we introduce a quantifier, at the same time, or when we use a quantifier, at the same time we introduce a variable which is going to stand for the typical element of the vector. Okay? So for each I, where I is going to be an index position into y, then we can say something about the value that's held in position I and the position I plus 1. Okay? So the quantifier for each has a variable that comes with it. We could call it I or j or whatever you'd like.